Okay, so in our second lesson, we're going to really focus on that unit circle and start working with the 6 trigonometric functions of the unit circle. And to begin with, let's go over what does that mean. Well, first of all, when you were back in Math 2, you studied 3 of the trigonometric functions when you studied some old hippie, caught another hippie tripping on acid. Because you studied sine, cosine, and tangent. But that's just 3 of the trigonometric functions. There are 3 others. And there's a relationship between them as such that we write them in a specific way so we can see the relationship. The first one is cosecant. The second one is secant. And as you'll notice, the 2 that are written side by side, if it starts with an S, then the other one starts with a C. If it starts with a C, then the other one starts with an S. So that makes it really easy to match those 4 words together. And tangent's really simple because it's cotangent. So that's another really simple thing. Then we write 2/3 next to each one because that's the angle that we want to find the trigonometric ratio with. You see, in these problems, some old hippie called another hippie works really well for what you used to do to find the trigonometric ratio or the fractional relationship from a right triangle. But now what we're planning to do is look at it from a graphic point of view. So let's start off with our XY axis, and we know if we go over here and look at 2/3, that 2/3 is up here at the top. The first line past 90 degrees. Alright, so let's go back and put that on our graph. Well, it's trying to move my graph. First line past 90 degrees. And we're going to turn that into a circle. The best you can, draw a circle around it. And drop that from the point on the circle down to the x-axis so it makes a right angle with the x-axis. And that's going to be our triangle that we look at that's a right triangle. Now, we're also going to go back to the unit circle and pick up something else. You see, each of these points that we made represents the cosine and the sine of an angle that can be made with that radius of the circle. You see, any point here, when you look at it from the center out to the circle, is a radius. And when you drop that line down, it becomes the hypotenuse of the right triangle. But it's also the radius of our circle. And so this point out here, -1/2 square root of 3/2, is a ratio relationship of the 3 sides of this triangle. So I'm going to take that point back and we're going to discuss this in detail. So our point is, don't you just love the way smartboard won't write? -1/2 square root of 3/2. So first of all, it makes sense that the x's are negative because I went left and that the y's are positive and I went high. But this is not an xy point. This point is a cosine sine point. And let me explain what that means. This is a trigonometric ratio. You see, cosine is x over r, and sine is y over r. So right now, we're not going to focus on some old hippie called another hippie tripping on acid because we're doing it with a coordinate plane. And therefore, we need to tell how it relates to the xy axis. So the top number on each one is an x and a y. The bottom number is your radius. So my radius of my circle is 2, and my x is equal to -1, and my y is equal to the square root of 3 because x is always off the cosine and y is always off the sine. So we already know 2 of these trigonometric functions out of the 6 because this point gives us 2 of them. So we can go ahead and fill those 2 in. Square root of 3/2 for sine because it's the second value. and negative 1/2 for cosine. Now, I've always thought it was interesting how that they list sine first instead of cosine first, since cosine comes first in a point. But I found out that the reason they do that is because everything in mathematics is always about what y does, because when you find out, plug a number in, you get a function of y with a y point, so you can plot it. Rise over run deals with y first. So a lot of y equal to formulas, everything's about y first. Now tangent's formula is y over x. So I can go back to this point and pick up these two values off the top of them, or I can go back to my picture and pick this y and x off the picture and get square root of 3 over negative 1, which divides that to be negative square root of 3. Because you don't need a 1 on the bottom, you just need to divide that out. Now, I could have also got that from just taking the top of the sine and the top of the cosine sitting here in my trigonometric set. And that's probably the best way to go about it, because once you get the sine and the cosine written, the tops of them are the tangent. Now, the formula for cosecant is r over y. And you'll notice that the formula for sine is y over r. So to make the other three, they're just reciprocals of the first three. So you flip those over and say 2 over the square root of 3. Now when you flip a fraction that's got a negative on it, keep the negative on top and just flip the numbers, because negatives don't move to the bottom of fractions. And then on this one, we'll have negative 1 over the square root of 3. Now, the middle one divides out evenly to give you negative 2. But these other two need that process we used to work on in math 2 and 3, I believe. It's called rationalizing the denominator. And so to rationalize the denominator, you've got to get rid of the radicals. So we do square root of 3 over square root of 3. And that comes up to be 2 square roots of 3, because you can't put those together on the top. And a radical times a radical, you multiply the inside, so 3 times 3 is 9, and the square root of 9 is 3. Now, the key is, it does the same thing every time. When you multiply two identical radicals, it just drops the radical every time. So because of that, you could just learn that rule that it drops the radical. Square root of 3, won't write again. Square root of 3 over square root of 3. Again, negative 1 times the square root of 3 is negative square root of 3, because you don't need to write the 1. Radical times radical drops the radical and keeps the number 3. So this is how you write the 6 trigonometric functions. Now when I grade this, I expect them to be in this order. I expect the two that are side by side show the reciprocals, and that they're listed in this order. If they are not, I will take off, because this is the order they should be. In fact, you can't mess that up, because sine, cosine, and tangent are in that order on the calculator from left to right, and we read from left to right. And then you just have to list the other three based on which two get paired together. And again, sine and cosecant go together because they have a S and a C at the beginning. You don't put the two with the S's or the two with the C's together. You want them to have opposite letters, like sine and cosine have. So our next one, we're doing 405. See, that last angle was an alpha angle, but this is a gamma angle, so we need to take away 360 so we can look it up. Now that comes out 45 degrees. So when we come over here and look at our unit circle for 45 degrees, we can see we're going to draw, let's throw that away. We can see, okay, it's going to draw out to here and come straight down. So that's kind of what we need to be able to draw on our circle when we bring it back over to the other page, and put the point square root of 2 over 2, square root of 2 over 2. So first, we're going to draw an XY-axis with a circle on it, or you can draw the line first out to the and draw the circle to touch it. I think sometimes it's easier to draw the circle first and then put the triangle inside. The point we pulled over is square root of 2 over 2, square root of 2 over 2. This is X over R, and this is Y over R. So you're going to need to memorize those formulas, and that's always is in order of cosine first, sine second. And that's not hard to remember either because cosine comes alphabetically before sine. A lot of times things in math are all about alphabetical order. So this is x equals the square root of 2 and y equals the square root of 2. And then the radius is equal to 2 because that's the number on the bottom of both of them. So now that I've got my picture drawn, we're talking about this angle right here. So that's a reference angle. And if you go back and think about what we did before, we drew the xy axis and we spiraled. We went around once and came back to there. So that little angle in there is the reference angle. To show, well, I need to lay my marker down. To show that spiral is just this little piece here is the same, stops at the same place. Same thing's true about this one over here. I can spiral around to this angle, but this angle inside here is really the angle that represents the triangle that has the same answers as the angle for the reference angle. So now we need to list out the 6 trigonometric functions. And as we list these 6 trig functions, we're going to put 405 with it, not the 45 that we looked up. That's the reference angle that we looked up. But we want to look up 405 and see what it is, and that's why we changed it to 45 so we could look it up. But we're really doing 405, so we have to write 405 on each one. Now, I'm going to pick up these 2 fractions and list it on the sine and the cosine. And 45-degree angles always have the same 2 numbers. So because of that, everything on the 4th lines have the same 2 numbers. Now it's time to do y over x. Now when you do y over x again, you can come back over here and look at your picture because you have x and y labeled. You can pull it out of the point because it's the top 2 numbers. Or you can just come over here to the 2 fractions and say, I want to take the top of these 2 because that's y over x, and write it down. Any way you do it, of those 3 thoughts, you get the same thing. The square root of 2 over 2, square root of 2 over square root of 2 divides out to make 1. Now it's time to do our reciprocals. So 2 over the square root of 2, 2 over the square root of 2, and if I flip this, it'll be the same, so it'll be 1 still. Now let's rationalize the denominator. Square root of 2 over square root of 2 rationalizes the denominator here. So that's 2 square roots of 2 over 2. These both cancel due to fraction rules, so the answer to this is just square root of 2. Because secant has the same fraction, it's also square root of 2. So our 6 trigonometric functions this time had some similar answers due to the fact of that reference angle being 45. We can do this also with negatives. Negative angles are what we call beta angles. But first, we would want to figure out where that beta angle is. Now, because that angle doesn't fall into the category of being too large to look up on my unit circle and reflect, that's what we're going to do. Alright, let me erase a little bit of this. So, negative 5 pi over 6 is here. So we're going to reflect it, and it's going to be down here. So now we know that's where our triangle needs to be. It's in quadrant 3, the first line down. So we're going to approximate that with our circle that we're about to draw. Alright, so we're going to put this line in here at the where we think the 6th line would be and make it come up and hit the x-axis to make that right angle. And we're going to go back and pick up that point. The point at this is the square root of 3 over 2 and 1/2 all the way around. There's a lot of those, but in this quadrant they're both negative. So that's important to pick up also. So negative square root of 3 over 2, negative 1/2. So that's our x and y on the top and our r's on the bottom. So if x in this problem is negative, it should have gone left, which it did. And y is negative 1, and it went down 1, and r is equal to 2. So the sine of negative 5 pi over 6, cosine of negative 5 pi over 6, tangent of negative 5 pi over 6, cosecant, secant, and cotangent. So now let's look at sine has already been given to us as negative 1/2, and cosine has already been given to us as negative square root of 3 over 2. So now we're ready to find the tangent. Remember, the tangent is y over x. So therefore, we could just pick the top number off of each of these fractions. Look at the picture, it's the same numbers, or wherever we want to look at it for. Picture, point, tops of these two fractions. Now a negative divided by negative cancels, but if I put square root of 3 over square root of 3, I get the square root of 3 over 3 because 2 radicals drops and becomes 3. Now over here we're going to reflect it, or should I say flip it, and make it negative 2 over 1, which is negative 2. Here we're going to move the 2 to the top and the square root of 3 to the bottom, so it's going to need rationalizing. So square root of 3 over square root of 3 is going to make it negative 2 square roots of 3 over 3. And then this last one, I'd go back to what it was before it was rationalized to flip it. That just makes the math a little easier. Negative square root of 3 over negative 1 divides out to give positive square root of 3. So in each of these problems, we've been given an angle. Now you're not always given what angle. So let's look at the next example. Well, we have one more with an angle. I forgot. We need to look at one that has an angle that's on the axis, because the angles on the axis are a little bit different. First, we've got to take 2 pi away from this. So we need to change this to be halves so that we can subtract. So if I put this over 1, it looks like I multiplied the bottom by 2. So I multiply the top by 2 and get 4 pi. That makes it pi over 2. So that's my angle I'm going to look up. I can see that's at the top and that it is going to be 0, 1. Now, if I connect that to the point that's supposed to be my radius, the problem is that for that would have to be the hypotenuse of the right triangle, because the radius is always the hypotenuse. Now it has to go out 1, and that's the distance 1. So the only way to connect those two is to connect it this way. And as you can see, the radius of my circle is not the hypotenuse of my triangle. So the ones that are on the axis, you can't draw a circle with a triangle inside of it. So you have to be able to do it just from the point 0, 1. Alright, so we have our point 0, 1. Now I need to make these fractions by putting 1s under them, because in this case 0 is x and y is 1 and the r would be 1. And that's why I can't draw the picture. It's because the radius is equal to y, and the radius is supposed to be the hypotenuse, which is supposed to be the longest side. But I still can write the 6 trigonometric functions. I just can't draw the picture. So that saves a little bit of work. So I'm writing out the 6 trig functions with my angle. So we already know that the sine is 1 and the cosine is 0, because that was the original point, and the original point always gives you those two. Now this is y over x, and y in this point is 1, and x is 0. So 1 over 0, if I divide that out, I cannot divide by 0. That is not something mathematicians have ever figured out how to do. I can have 0 on top because 0 divided by 1 is 0. But when 0 is on the bottom, it's undefined. Now, if you flip 1 over 1, you get 1. And if you flip 0 over 1, you get 1 over 0. So again, we get it undefined. And then, if we flip this one, it becomes 0 over 1, or 0. So you get some kind of strange answers when you get one on the axis because you can't flip and divide by 0. Alright, I want you to stop the video for a moment, and you need to go into the assignment. There are 3 sets of questions. If you want to do any of the questions before you move on, this would be the middle set, something around in the 40s. Alright, so we have 2 more questions to go. This one is like the first set of problems, and the last one is like the last set. And it's the same process, except for I don't know what angle it is anymore. You see, this angle is not on the unit circle. There are no square roots of 21 on there. And just to prove that to you, I'll pull up the unit circle. As you can see, if you look all the way around it, all the square roots are square roots of 2 and square roots of 3. There are no square roots of 21 on here. That's because this angle is going to fall somewhere in between all of these. And when you look at the number negative 2 comma square root of 21, let's go back to the unit circle, then that's going to go left and up. So I know it's going to be somewhere in quadrant 2. Now the square root of 21 is more than 4. So I've got to make it twice as tall if I've got 2 comma 4 point something. So I'm expecting it to come over some and go up a lot more than it goes over. So I'm going to put it up there near where the 120 angle is. So I'm going to draw my circle, put my triangle in there such that x is equal to negative 2 and y is equal to the square root of 21, which makes it look taller because I told you that's about 4 point something, and r is equal to 5. So there is my picture. So now when I do the sign, I don't have an angle to put here anymore, so we use the generic letter theta because we don't know the angle. So we write out all 6 trig functions. We already know the answer to the first 2. Square root of 21 over 5 and negative 2 over 5 is my trigonometric ratios. This is my labeling of my picture so that I can realize that that's true because sine is y over r and cosine is x over r. And again, if you take the top of those 2 and make it y over x, you get your tangent. So that's going to be square root of 21 over negative 2, and we're going to move that negative up and make it negative square root of, well, that looks really bad. Let me try that again. Negative 21 over 2. You don't want to leave a negative on the bottom of a fraction, so make sure that you always move the negative up. So now I'm going to flip it, 5 over the square root of 21, and I'm going to rationalize that. Now, what I'm hoping at some point in time, after you've done a few rationalizing problems, you'll be able to say, oh, it just adds the square root to the top and takes the square root off the bottom. But if that doesn't work, then go in there and write the 21 inside the square root on each one. This one will be negative 5 over 2. This one will be negative 2 over the square root of 21. So when I rationalize that, that's going to come out negative 2 square roots of 21 over 21. So see how that works for you in terms of rationalizing. But if you need to write those radicals on there, write them on there. I'm hoping that that will eventually come to be something you can do in your head, though. All right, our last point it says it's not on the unit circle, so let me explain that to you. So if I draw the unit circle, this quadrant point is over to the left and up, so it makes it quadrant 2. So if I go over 3 and up 4, make my triangle. A lot of students think you just need to put a 1 under each of those. Well, let's talk about that. X equals -3, Y equals 4. Now, if I look at that picture, I realize really quickly that the hypotenuse of this triangle, the radius, has to be more than 1 because it has to be the longest side. And if I put 3 over 1 and 4 over 1, then this is not going to work in Pythagorean theorem. It's not going to be the longest side. It is not going to be the hypotenuse. So that is not what you do when it's not on the unit circle. What this really represents is a true XY point. Our job is we've got to convert this to an X over R, Y over R point. So to do that, you have to use Pythagorean theorem to find your R. So x squared plus y squared equals r squared is, first of all, Pythagorean theorem, but representing the letters on this triangle, I have put in the x, y, and the r instead of the a, b, and c. But what that really represents is the equation of a circle with center 0, 0, which is a conic. And we'll go in a lot of depth later in another unit on conic equations. So just think of this as Pythagorean theorem. So I don't need negatives because I'm getting ready to square. Distances aren't negative, so don't put the negatives in this formula. Just put the positive numbers. So 3 squared plus 4 squared will be 9 plus 16, which is 25. The square root of 25 is 5. Now this is what we call a Pythagorean triple. 3, 4, 5 always go together. So anytime you need this 3, 4, 5 pattern, you should just memorize it. There's about 3 of these that they use a lot. But 3, 4, 5 is one. They double all those and get 6, 8, 10. And then the other one is 5, 12, 13. They use those Pythagorean triples tremendously, so it would be to your advantage to use those all the time. Now, let's go into the next part, which is how to write my statements now. So now my points have a 5 on the bottom, and I've turned it into a sine cosine point instead of an xy point. So we have the sine of theta is 4 over 5. The cosine of theta is -3 over 5. The tangent of theta, remember again, it's y over x, so it's just the top of each one of these, -4 over 3. And it would be best when you're doing this that you don't circle those. I'm doing it for emphasis here in our notes, but I don't want you doing that when you're doing the work. Then cosecant of theta is the reciprocal, 5 over 4. Secant of theta is equal to -5 over 3. And cotangent of theta is equal to -3 over 4. So those don't need any rationalizing because there are no radicals. So in this lesson, as you can see, we have a tremendous amount of taking apart fractions that represent ratios and seeing how to put them together with different comparisons. Now you can go to do 5.2 Part 1 homework, and make sure you look at the list that I asked you to do, because I'm not asking you to do all the evens. I'm only asking you to do certain even questions with that assignment.